Alright my friends, and welcome to this video on improper integrals part 1. And in this video we're going to talk about what happens if we have infinity or negative infinity as a bound of my integral. So we're going to talk about all the different integration techniques, but we just have something different we need to do when infinity is a bound. So just as a general question, so what is the integral from 0 to infinity of, I don't know, x squared? Well, I hope that you can look at this and just say okay, well, obviously that's an infinite area, right? If we have x squared, it's a parabola. And if we want to find all the area from there, all the way over to the right, towards infinity, that integral is obviously going to be infinite. Now, the more interesting question is that what happens if we have an asymptote there? And we're going to talk about how to handle that now. So for example, suppose we have to find what is the integral from 1 to infinity of 1 over x squared. Because graphically, what's going on here is 1 over x squared has a very sharp asymptote. So if we're finding all the area from 1 to infinity, that means all the area from 1 on to forever. Now it turns out that even though we go infinitely far over to the right, because this function actually gets infinitely short, infinitely close to the x-axis, right? Like the height goes to 0, that area is not always going to be infinite. Sometimes it might be a number. So here's kind of the overarching idea that you need to make sure you get. You can't integrate to infinity because infinity is a concept. So what you need to do is instead of integrating to a concept, what you're going to do is write it as a limit. So when you write it as a limit, you're going to make up a variable for the infinity. So just pick your favorite letter. I'll pick A because that's the kind of grade we all want to get. So we're going to take a limit as A goes to infinity of 1 to a of 1 over x squared. So what we're basically doing is saying, okay, we go from 1 to a and ask ourselves, what is the area between those 2 points as that a just goes infinitely far over to the right. And hopefully you can see that this limit is identical to that integral that we want to find. So after we wrote it as a limit, then basically what we're going to do is we're going to calculate this integral and then plug in the a. And then once we've done that, then we will take the limit as a goes to infinity of our answer. So I'm just going to leave this limit out in front here and say, okay, I'm going to take a limit as a goes to infinity of, okay, so how do I integrate 1 over x squared? Well, that's the integral of x to the negative 2, so that's x to the negative 1 over negative 1, so that's negative 1 over x going from 1 to a. So this is going to be the limit as a goes to infinity. I know it gets boring to write the limit every time, but that needs to be something you do. It's just going to be part of the problem they're going to look for on the AP test. If you're not writing it as a limit every step, you will not earn full credit. Okay, so this just becomes negative 1 over a plus 1. So again, we're going to take our limit as a goes to infinity. So this is going to become negative 1 over infinity plus 1. Well, as you guys know, anything over infinity is 0, so this becomes 0 plus 1, so my answer is 1. Okay, so that's how we handle an integral to infinity. We write that as a limit, and then again, this is just the area for all x that are greater than or equal to 1. Everything from 1 to infinity. In this diagram in pink, that's the area we found. Exactly 1. How cool is that? Okay, let's look at a couple more examples. Let's do the integral 4 to infinity of 1 over x dx. Now again, when you look at a problem like this, when you see infinity as a bound, what you need to do is write it as a limit. Before you do any integration, let's say, okay, I'm going to take a limit as a goes to infinity. You could do g to honor your teacher or whatever, from 4 to a of 1 over x. Okay, so when I integrate 1 over x, I'm going to get the natural log of x, of course, going from 4 to a. So I'm going to be taking the limit as a goes to infinity of the natural log of a minus the natural log of 4. Okay, so again, I'll go ahead and actually take the limit. So this is going to become, oops, I don't need to write that. So this is the natural log of infinity minus the natural log of 4. Now, as you guys know, that's obviously infinite. So the natural log of infinity is e to what power equals infinity? That's infinity. So this is infinity minus ln of 4, which is infinite. Okay, so well, obviously that just means you have an infinite area, right? So if you have 1 over x, kind of looks like that. It's just saying if you take the area from 4 on to infinity and measure that area, it's a truly infinite area. Okay, so let's talk about some vocabulary. So just some vocab terms that we're going to be using quite a bit over the next couple days. We say an integral is convergent if the limit, or the value, so if it is a real number when you take the limit. It is divergent, like Shailene Woodley, it is divergent if that limit does not exist or is plus or minus infinity. So those are words we're going to use a lot actually in the next two chapters, but we'll start using them now. So because we got infinity, we could say that this integral is divergent, or the integral diverges. Okay. In this one, where we got a limit of 1, we would say this is an integral that converges. The value of that limit goes to 1. Okay, so those are just some vocab words to get used to. All right, so let's look at another example here. So let's suppose some chump asks us to find integral from negative infinity to 1 of e to the 2x dx. Okay, now two things to keep in mind here. So first off, when you have negative infinity, it's the same as positive infinity. You're just going to write it as a limit. The other thing I wanted to remind you on this type of problem, to help make your life easier, do the u sub first, including changing the bounds. Do the u sub first, change the bounds, and then write it as a limit. And that's just going to make the whole process of actually taking the limit easier, because your u is not going to be all messed up. Okay, so when you look at this problem, right, it's e to the 2x. So obviously we're going to choose the 2x to be my u. So u is 2x. The derivative of that is 2 dx. So I need to change my bounds here. So we go negative infinity to 1. 2 times negative infinity is negative infinity. 2 times 1, I'm pretty sure, is 2. So this is going to become, let's see, we need a 2 here, we need a 1/2 in front. So this is going to become 1/2 times the integral from negative infinity to 2 of e to the u du. Now that I've done the u sub, now I want to write this as a limit. Okay, so now this is going to be the limit as a goes to negative infinity. So again, same thing, of 1/2 integral a to 2 of e to the u. Cool. Not bad, right? We just got a bunch of new variables that weren't even in the problem to begin with. So now let's go ahead and actually do this integral. So this is a very easy integral because we did a u sub. So it's 1/2 e to the u going from a to 2. We take that limit there. So this is going to be the limit as a goes to negative infinity of 1/2, and then that's e squared. We can just leave the 1/2 in front or distribute, it doesn't matter, e to the a. Okay. So I did the integral, I plugged in the bounds. Now my very last step is I want to take the limit. So as I do this, I'm going to get 1/2 times e squared minus e to the negative infinity. And as you might recall, e to the negative infinity is 1 over e to the infinity, which is 1 over infinity, which is 0. So this just becomes 1/2 times e squared minus 0. So my answer for this integral, this infinite area, is 1/2 e squared. Delightful. Okay. So that's the trick with negative infinity. And by the way, if you ever get in a situation where if you have both minus infinity and infinity, so for example, like there was a question like this on the AP test a few years ago. There's like negative infinity to infinity of 2x over 1 plus x squared. This is don't freak out by this. Just split this up. Just split it up at 0. I mean, you can split it up at any point, but it's easier at 0. So just turn this into the integral negative infinity to 0 of this function plus the area from 0 to infinity of the same function. You can split it up at 1 if that's your thing. It doesn't matter where you split it up, but just turn two separate integrals and do that. So that's how you approach that. Okay, so those are the straightforward cases, just doing some integrals, do some u sub. Let me show you a couple advanced cases, and then we'll go ahead and talk about this. So for the first example, and these are both old AP questions, so I'll ask you to find the integral 1 to infinity of 2f of x dx. And that you are given that g is an antiderivative of f. And g of 1 is equal to 5. And the limit as x goes to infinity of g of x is equal to 12. So that's the situation here. We don't have an equation for f. We know g is an antiderivative. So when I'm working with this now, when I'm starting with integral 1 to infinity of 2f of x dx, the first thing again we want to do is write it as a limit. So So I'll take this and say this is a limit as a goes to infinity. And again, you use whatever grade you want or whatever letter you want. I would not recommend using x, d, or c for obvious reasons. Integral 1 to a of 2f of x. Okay, now what did they tell me? They told me g is an antiderivative of f. Great, so if I integrate f, I'm going to get g. Okay, cool. So this is just going to be 2g of x going from 1 to a. Okay, so this is just going to be the limit as a goes to infinity of 2g of x minus 2g of 1. All right, so what did they tell me? Well, they told me that g of 1 is 5, so I can just plug that in there. And when we're taking the limit at, also I made a typo here, this should be an a, but if I'm taking the limit as x goes to infinity of g of x, that is the same as taking the limit as a goes to infinity of g of a. The variable doesn't matter, right? If you take the limit as a goes to 3 of g of a, that's the same as the limit as x goes to 3 of g of x. They're both going to g of 3. And it's the same thing here. So what this turns out to be is this is saying this is equal to 2 times, you remember you can pull a constant in front, so 2 times limit a goes to infinity of g of a minus 2 times 5. Okay, so they told me that limit, was 12, so this is just equal to 2 times 12 minus 10, which I believe is 14. Okay, so that's how you approach that problem. So you just work it out, write it as a limit, and then you just need to use that kind of piece of information there about the limit when you have to take the limit of g. Okay, one more problem I want to show you. This is a free response question I want to say about 3 years ago on the AP test. They told you to find the integral from 5 to infinity of 3 divided by 2x squared minus 7x plus 5, given that 3 over 2x squared minus 7x plus 5 equals 2 over 2x minus 5. Well, I wrote that poorly. So 2 minus 2x minus 5 minus 1 over x minus 1. Now, here's the good thing about this. When you look at this integral, they already gave you the partial fraction breakdown. They told you how you need to break this down into 2 different parts. So that's nice. That saves us the work. This is factorable, so we use partial fractions, but that's how you'd approach this problem. So when you write this, write this as a limit a goes to infinity or whatever, integral 5 to a, but when you do the integral, they did the hard part for you. Okay, now both of these integrals we're going to do separately, right? So I'll deal with the bounds later. U is x minus 1, put a dx on both of them. So they gave me the partial fraction breakdown, so my du is dx. U is 2x minus 5. My du is 2dx. That was very convenient. So we integrate here, 1 over u du. We integrate here, 1 over u du. Great. Anyway, so this becomes, we do those integrals separately. Limit a goes to infinity of. That'll be natural log of, let's say u. So 2x minus 5. And then minus the natural log of x minus 1 going from 5 to a. Okay. So let's go ahead and plug these in. So when we do this, we're going to get the natural log of, so the natural log of 2a minus 5 minus the natural log of a minus 1. Okay, and then that's the first part. And then plugging in 5 is easy, right? That's ln 5 minus ln 4. Okay, so nothing fancy happens there. So that's what I got. And now what happens as I take the limit? And this is where you're really going to love what we did last semester. Because if you take this limit on this part with the a in it, what you're going to get is ln of infinity minus ln of infinity. Infinity minus infinity. And what I want to remind you about that, infinity minus infinity is undefined. It's not a clear answer. What you need to do is write it as a fraction so that you can use our old buddy L'Hopital. Ooh, look at this review. Beautiful. So what we're going to do is we're going to take these logs, ln of something minus ln of something, and turn this into a limit a goes to infinity of the natural log of 2a minus 5 over a minus 1. And then, of course, here, like this part stays the same. Okay, so as you take this limit, like the top goes to infinity, the bottom goes to infinity. So what that means, we do L'Hopital's rule. And L'Hopital we can do on the inside of the natural log. We just take the derivative of the top and bottom inside that limit of the natural log. So this just becomes the limit as a goes to infinity The derivative on top and bottom is 2a minus 5, that's 2. A minus 1 is just 1. And then that turns out to be natural log of 2 over 1. So L'Hopital helped us define the limit in this case. So this just becomes the natural log of 2 minus the natural log of 5 plus the natural log of 4 when you distribute. Okay. And simplifying, I wouldn't worry about that. The key here, and this is obviously like the most challenging problem, but the key was just to take the limit, right? Write it as a limit. In this case, they gave you the setup for what the fractions are. And we just got to a point where we had like an infinite limit over an infinite limit, and that was where we needed to use L'Hopital's rule. But most of the problems on your homework are going to be straightforward, like the first couple we did, where you're just taking a relatively simple limit, maybe do a use up first. All right, thanks for watching, guys. Bring me some questions to class, and I'll see you guys soon.